welcome to my channel. Okay, let's go to the topic. NASA science experiments on next northrop grumman space station mission. Okay, today's topic is International Space Station NASA Northrop Grumman by NASA February 5, 2022. See this picture. Scientific investigation on skin again and the tumor cells along with test of the technology of oxygen production, bacteria and growing plants all travel on the 70th Northrop Grumman's commercial resupply service mission to the International Space Station. The Cygnus spacecraft is scheduled for liftoff. No airline than the Saturday, February 19, 2022 from NASA's Wallops Space Facilities on Wallops Island, Virginia. Here are details on the some of the scientific investigation traveling to the space station on the mission. Preparation of tissue culture plants for Colgate skin aging, which evaluate change in skin cells in microgravity on could help provide a model of the assessing product for protecting skin from the effect of aging. Credit Colgate Palmolive. Deterioration of skin tissue, a normal part of aging, occurs over decades. Microgravity leads to change in the body that are similar to aging but happen much more quickly in space, where it can be more easily studied. Then on Earth, the Colgate skin aging experiment evaluates cellular in molecule changes engineered human skin cells microgravity. Aging related skin changes are not simply cosmetic, as the body's largest organ skin performs multiple functions, including protection from infection, regulations of body temperature and sensory input. Loss of functions or structure stability in skin therefore can be protection source of the other health problem. Results from the experiment could show these engineered cells may service on the model rapid access productive aimed at protecting skin from the aging process back on Earth. This image shows the immunofluorescence of breast cancer cells treated with the microqueen therapeutic. Starting shows on the normal nucleus blue and the therapeutic green, localized to the cell's endoplasmic reticulum red. The drug force in cytoskeleton yellow to collapse, including cell death. Credit Scott Robinson, microqueen. Testing tumor drugs. Microqueen 3G tumor examines in the effect of the drug in breast and prostate cancer cell in the space in microgravity. This cell can grow in a more natural three-dimensional model, which makes it easier to characterize their structure. Gene expression, cell signaling, and response to the drug. Result could provide new insight into the cell protein targeted by the drug and help advance development of the drug in the targeted cancerous cell. Our 3D tumor modeling investigation on the space station provide a phenomenal opportunity to study cancer more naturally, allowing us to better assess drug penetration, tumor response, cell-to-cell signaling, disease progression, and even how drug resistance can emerge, says Scott Robinson, microqueen principal investigator. Cancerous cells ignore signals to stop the growing, stop dividing, or even to die in microgravity. The signals change considerably and either benefit cancer growth. Knowing what signaling pathways are affected and how allow us to focus research effort to the defining new therapeutic interventions that are more effective, less toxic, and have better patient outcomes. Hardware for the OGA-H2 sensor demo shown in preparation for flight. The technology demonstration tests a new sensor for the detecting hydrogen in oxygen generating a system on spacecraft. Credit NASA's Marshall Space Flight Center. Improving hydrogen sensor. The OGA-H2 sensor demo tests new sensors for the space station's oxygen generation system (OGS). The OGS produces breathable oxygen via electrolysis or separations of the water into hydrogen and oxygen. The hydrogen is either vented overboard or sent to a post-processing system where it is recombined with the waste carbon dioxide to, from water. Current sensor ensures that none of the hydrogen enter of the oxygen stream into the cabin, but are sensitive to moisture, nitrogen, drift in calibration, and other issues that can cause problem. They must therefore be swapped out after every 201 days of issue. This technology could provide more durable sensor for the situations where replacement is not practical every 201 days, reducing the number of the spare needed on larger space missions such as the Moon or Mars. Improved technology for monitoring oxygen generation system also has potential application for the contained environment of Earth, such as the underwater facilities and those in a remote and dangerous location. The Space Asleep hardware is shown undergoing thermal vacuum testing prior to launch. Credit JAXA. Better batteries. An investigation from the Japan Aerospace Exploration Agency JAXA. Space Asleep demonstration operations of the lithium-ion secondary battery capable of the safe, stable operation under extreme temperature and in a vacuum environment, and flame retardant materials and that does not leak liquid, making it safer and more reliable. Result could demonstrate the battery's performance for the variety of the potential use in the space and other planetary environments. Solid state batteries also have potential application in the harsh environment and in the automotive and the aerospace industry on the earth. See this picture. Green onion plants growing using aeroponics are the held to display their roots. The X-root study testy hydroponic water-based and the aeroponic air-based technique to grow plants in the space. Credit Syria space. Plants in space. Current systems for the growing plants in space use soil or a growth medium. These systems are the small and due to not scale well in the space environment due to the mass and environment and sanitation issues. X-root tests using hydroponic water-based and the aeroponic air-based techniques instead, which could reduce the overall system mass. The investigation takes the video and still image of the root zone and the crop for evaluation of the plant life cycle from the seed germination to throughout the maturity in multiple independent growth chambers. The investigation incorporates unique root models designing to the provide delivery and the recovery of nutrient solution to the plant so they can be growth without the additional mass of any soil media. Explain the principal investigator John Wetzel of the Sierra Nevada Corporation. This approach is much more mass efficient for future large-scale plants growth system in space. Results could provide insight into the development of large-scale systems to grow food crops for future space exploration and habits. Components for the system developed for the investigation also could enhance cultivating for the plants in the terrestrial settings such as greenhouses and contribute to better food security for the people on Earth. Improving fire safety. The solid fuel ignitions and the extraction SOFIE facilities enable studies on flammability of the materials and the ignitions of the fires in realistic atmosphere conditions. It uses the combustion's integrated rack CIR, which enable testing at the different oxygen concentrations and the pressures representative of the current and the planet space exploration missions. Gravity influence flames on the Earth, but in microgravity about to the space station, fire acts differently and can be behave in the unexpected ways. Some evidence suggests that the fire may be more hazardous in the reduced gravity, a safety concern from the future space mission. Results may improve understanding of how fires start and grow in the reduced gravity, helping to validate methods for testing and models for the predicting the flammability of the spaceflight materials and the models. These insights could help the ensure crew safety by the improving disease of the extravehicle activities, shoots, informing selection. Sorry for little bit mistakes in this video because I am making the video in nowadays. Thank you for watching. Subscribe my channel. Bye.